So let's go through the demo. I'll show you effect of embedding models, advanced retrieval strategies, re-ranking, and context compression. We'll cover quite a lot, actually. Okay, so again, we are using the same LangChain dependencies here, nothing special. Also connecting to Hugging Face. Here I've downloaded a data set which is extracted from Wikipedia, basically, okay? And I've just loaded the data here from the zip file and filtered out data just for documents related to India, so I could run this faster. This is how documents look like. Like here you have a document on Basil, and so on, right? Different documents. Here's a document on the Indian Air Force, and so on. So let's see the effect of different embedding models. The first embedding model you see here is a very popular one from sentence transformers. It's based on a modification of a BERT model. This is a very old model, by the way. So we load up the model. We create embeddings for each of our document chunks, and we put it in the vector database, as you can see here. And then we put retrieval strategy, simple cosine similarity, retrieve the top 2 similar documents to any input question. And we ask what is the capital of India. So you can see that it is retrieving 2 documents, but none of them are relevant to answer the question. We ask the second one, what is the old capital of India? You do get New Delhi, but you miss out on Kolkata, which is the old capital of India. Let's try a different embedding model. This is one of the top ones in the benchmark from MixedBreed AI. Very useful embedding model. Open source, again, or open weights. So now we create a vector database, again, a separate one, with the same documents, different embedding model. So now if you see here, you get the right documents. This one is the right document. You get it as the most similar document. Old capital, first one is New Delhi, which is still OK, but you do get the right document in the context, the second document. So the main thing here is the embedding model can have a really profound effect. So don't ignore the embedding model. And then we tried the recent OpenAI embedding model, same thing again. In this case, this is the correct one, retrieved. In this case, it somehow misses out. So the open embedding model actually performed better in this case. Maybe if you took the top 5 relevant chunks, it would come in, probably. Let's look at multi-query retrieval now. So how do you do that? To do multi-query retrieval, you need an LLM. Then you need to make the generate variants of your input question, and then you send each of those questions to the vector database, and then collect the common retrieved documents. So here we have a cosine similarity strategy on our vector database, and we just wrap it over the multi-query retrieval. So what will happen is, this retriever will make the LLM generate 3 questions, which are just variants of our input question, and then it will run the cosine similarity retrieval process. So if we ask the same question now, you can see that it is actually generating 3 questions, which are variants of a question. Which city serves as the capital of India? Which city's administrative capital? Can you tell me the name of India's capital? So asking the question in different ways can often retrieve the documents in case they are missed. I've seen some instances where multi-query retrieval can work pretty well. Okay, and as you can see, old capital of India is fine, but there are better ways to frame it. Like, what is the capital of India before New Delhi? That's a great way to frame it. What city served as the capital of India in the past, or former capital? So different ways of expressing your query to retrieve relevant information. Okay, that's one thing. That's multi-query retrieval, basically. Now let's talk about hybrid search. This is very useful. When I said in your description or your documents, you have things related to specific entities, terms. Like in this case, let's say we have a bunch of documents about various laptops. Various laptop models contains the processor configuration, RAM, SSD, and all of this stuff. So we just dump it into a vector database using the OpenAI embedding model. So now we have created a simple semantic retrieval strategy, simple cosine similarity, just like before. Retrieve top 2 documents, and we also create a BM25 retrieval index, which means use BM25, which is a keyword-based retrieval system, which is basically a modification on top of TF-IDF. And then you can create ensemble retriever, where you are kind of combining both of them, saying give 70% weightage to the keyword-based retrieval and 30% weightage to the semantic retrieval. Now, if you ask this question with just cosine similarity, so here I'm not using the ensemble retrieval, I'm using the simple cosine similarity first on this question. Laptops with 16 GB RAM and processor i7-1065G7 Intel. So if you see here, 16 GB RAM is correct, but the processor is not the right one. The first retrieved document. Second one is correct, more or less. But if you do the ensemble retrieval, same query, you can see that it actually ends up retrieving the most relevant document at the top. Okay, so that's where you can think of, based on your data, if keywords are very important, not just meaning, then go for a hybrid retrieval strategy. Chain retrieval is where you can retrieve and re-rank one after the other. How do you do that? First, set up your base retrieval strategy, which is just, in this case, let's say cosine similarity. Load up re-ranking model. So a re-ranking model is a cross-encoder, which means it takes a question and document, and it gives you a relevancy score. And then you just combine it in the contextual compression retriever, saying first retrieve using cosine similarity, and then do the re-ranking. So now if we ask, okay, what is the capital of India? New Delhi is the first one. What is the old capital of India? Kolkata comes as the first one, right? Which we did not see before. So that's the effect of re-ranking, where re-ranking tries to not just do cosine similarity, semantic similarity, but it also tries to understand the relevancy. And the relevancy it only understands because it has been fine-tuned on hundreds of thousands of pairs of documents, okay? There are ways in which you can fine-tune embedding models, fine-tune re-ranking models also. All you need to do is use an LLM again to create a prompt saying, create pairs of question answers, question context documents, put it into the embedding model and train it. Sentence Transformers offers a really nice framework where in less than 30 lines of code, you can do this. Context compression strategies, if you have a lot of information in your context, it can sometimes become an issue for the LLM to get to the right answer. So here we will look at LLM prompt-based compression. LLM chain extractor is using an extraction strategy, which means it will remove parts of the documents which are not useful to answer the user question. So here we load up a connection to a GPT-4o model. We have the same base retrieval strategy here, cosine similarity. By the way, you can use other retrieval strategies also here. Like you can use the chain retrieval, you can use a multi-query retrieval. That is your base retrieval. And then we just wrap LLM chain extractor with the LLM and put that in the contextual compression retrieval. Just like you do retrieval re-ranking, here you are doing retrieval context compression. So your base retrieval will be cosine similarity based retrieval, and then you do the compression by using an LLM. So now if you ask what is the capital of India, in the retrieval you can see you have only one document, and you don't even have the full document. You only have the relevant part of the document, which is useful to answer the question. Same thing for the next one. So context compression can be very effective, but sometimes it can be very aggressive. You need to play around with this also. I like the LLM chain filter a bit more because it does not remove the full context document, like parts of the context document. So in case of LLM chain filter, again, you wrap the LLM in LLM chain filter, put it in the contextual compression retrieval, where your base retriever is cosine similarity, and then use the context compression based on the filtering strategy. Filtering strategy means remove entire documents which are not related to the input question, but documents which are relevant, don't strip away parts of that document. So if you see here, what is the capital of India? We get the full document of New Delhi. We don't strip away parts of it, which happened in the extraction strategy. And similarly, what is the old capital of India? We get back the Kolkata document. So hopefully you got some ideas. Many of you might have used some of these. Many of you may not have tried out some of these. Definitely explore these things. And again, like I said, go beyond the default settings of the tools you're using. Go beyond just simple cosine similarity. Okay, and now the last part of our talk.